So today we're going to be talking about angle relationships. Okay, so what does that mean? Well, if you have two angles, is there a name you can give them to talk about how they are related to each other? Well, I know that sounds really vague, but let's get into it and I'll show you what I mean. Okay. And one of them is to call two angles adjacent. Adjacent is a fancy way to say close to. Okay. And it means a specific thing in geometry. Okay. So it's not just close. Okay. It's so close, in fact, that two angles, they have to be on the same flat surface. So that's the first thing. But they have to have a common vertex, a common side, and they can't overlap. Okay. So when they say no common interior points, they mean not overlapping. So you can write that. Can't overlap. Okay. So let's look at an example. Okay. Angle one. Okay. Do you see this angle right here? The two sides that make it are going to be those two rays that are shown. Angle one is right there. The vertex is that point right here. Well, angle two shares that same vertex and it has that same ray on the side. So a common ray, a common vertex, and they don't overlap. So angle one and angle two don't overlap with each other. Okay. So angle one and angle two, and the relationship they have would be that they're adjacent. Okay. And so it means close to, but it also means this very special thing. So angle one here, notice it's formed right here, and the vertex is right here. And angle two shares that common vertex, and it also shares this common side here. Okay, and so angle one and angle two, indeed, on the second picture, are also adjacent to each other because they don't overlap. They have a common side, okay, and they have a common vertex. Now, the next one, if you just look at it, it does look like there's two adjacent angles. They look like they have the vertex at point B, etc. So what they're talking about here would be this, okay? There are two adjacent angles pictured, okay? But what they're saying is this: angle ABC. Okay, where's angle ABC? Angle ABC goes from A to B to C. It's this whole big old angle, okay? And if you notice the vertex is angle B, the sides are BA and BC, okay? And then if you're talking about angle 3, now notice it has a lot of the same things. It does have a common side, okay? This side over here, it does have a common vertex. However, it does overlap. So if you say angle ABC and then also angle 3 overlaps it, okay? So angle ABC and angle 3 are not adjacent because they overlap. Okay, so that would be good. Now, the next thing is another non-example would be angle 3 and say also angle ABC. Well, they don't have a common vertex. They don't have a common edge, okay, side, and um, they don't overlap, but still it you have to have all three things to be adjacent, okay? And so that's true. So one relationship would be two angles could be adjacent to each other if they have these three things: common vertex, common side, and they don't overlap. Okay. The next one is called a linear pair. So a linear pair is a pair of angles. Okay. And this is spelled wrong, so we should fix that. So a pair of adjacent angles, okay, whose not common sides are opposite rays. So if you've got a pair of adjacent angles, okay, whose not common sides are going to be, I should make this a special thing, are going to be opposite rays. Okay, so DA and AB, okay, AD and AB are opposite rays. And notice the ray that separates them is going to be AC. Okay, so here is one angle right here, DAC, and here's the other angle that's adjacent to it, CAB, and together they make 180 degrees. Okay, and so what is the common side? The common side is ray AC. What are the opposite rays? So AB and AD. Okay, so we've got a opposite rays, we've got a common side. And then also, what is the name of the angles that form that linear pair? They are going to be angle DAC and angle CAB. And what appears to be true? They make 180 degrees. Okay. Okay, so that's true about all linear pairs. The sum of the two angles who are linear pairs makes 180 degrees. So linear pair is as shown. You've got adjacent angles who make 180 degrees, and they're sitting right next to each other. They are going to be formed with opposite rays, and then also that common side, but their sum is going to be 180 degrees. So that's kind of special. Okay, vertical angles. That's our next one. Okay, vertical angles right here. There's a lot of words here, and let's just try to simplify it. If you just start by drawing two axes, actually one X by drawing two lines. So if you draw an X drawing two lines, anytime you draw an X drawing two lines, you form four angles. And the truth is that this angle here with that angle there, those are going to be called vertical angles, and they will always be congruent. Okay, and so angle 1 and angle 3 are vertical angles, and they'll be congruent. And then also, okay, angle 2 and 4 are also vertical angles, and they'll be congruent to each other. Okay, so this one will match this one right here. So anytime you draw an X, opposite angles are going to be called vertical angles. They kind of make like a V. Okay, you can kind of imagine that. And then also this vertical angle and this vertical angle will be congruent to each other, as well as the two on the sides. Okay. Now notice we can talk about the vertical angles being congruent. That's my favorite thing to speak of, but we do also have some adjacent angles as well. So notice that angle 1 and angle 2 are right next to each other, common side, common vertex, not overlapping, as well as say 2 and 3, etc. Okay, so there's a lot of adjacent angles. So 2 and 3, 3 and 4, 4 and 1. Okay, and so those are adjacent angles as well. So the next thing we can talk about would be complementary. You're so cute. No, you're so, no. Complementary is spelled differently than if you give someone a compliment. Complementary means that their sum makes a complete number. Okay, and that number they're talking about would be 90 degrees. So if the sum of two angles make 90 degrees, we call them complementary to each other. Okay, and they may or may not be adjacent. Okay, so may or may not be adjacent. And it's a fun game to play. What is the complement of a 10-degree angle? Well, 10 and 80 are complementary to each other. Okay. They have to make a good pair and they have to make 90 degrees. Okay. What's the complement of a 40-degree angle? Well, 40 and 50 degree angles are complementary of each other. They just work out to be a cute number. They make 90 degrees. To be supplementary, okay, you take supplements if you're trying to take like medicine to be like, oh, I'm going to take some vitamins. Another word for vitamins is supplement. And so supplementary have a good sum as well. And the sum of those two angles makes 180 degrees. So complementary's number is a little cuter. It's smaller. It's 90. Supplementary angles are 180 degrees if you add them up. So, and again, they may or may not be adjacent. And so it's a fun game as well to be like, okay, what's the supplement of 20 degrees? Well, 20 and 160 are supplements of each other. If you say, okay, 50, well, 50 and 130 are supplements of each other as well. So their sum has to make 180. Okay, perpendicular means that they form a right angle. Okay, and so an example of that would be AD is perpendicular to CB. And then when they intersect at a right angle, that means they form 90 degrees. Okay. Okay, another thing we're going to do is practice a little bit. Okay, so we're going to practice some of these skills. Tell me two angles that the best and only really word you can use to call them would be adjacent. We're not going to say they're also going to be complementary or supplementary. Let's talk about two angles that their best word would be that they are adjacent to each other. So angle PQT and angle TQS. Okay, those are two angles. PQT, okay, that's an angle right here. And then also TQS, they're complementary, or sorry, they are going to be adjacent. How do you say that they're adjacent? They have a common vertex, that's at Q. They have a common side, that's going to be QT, and they don't overlap. Okay. What would be another example of angles where you could say they're adjacent and they also make a linear pair? A linear pair means they make a line pair. They make a straight line together. Okay, they make 180 degrees. So they're adjacent and they make a line pair. Well, let's talk about this angle here. There's a couple options of what you could say. And then let's pair it with this angle right here. Do you see how they're adjacent? They have a common side right here. And their vertex is at Q. And they don't overlap. And they definitely make 180 degrees because they have opposite, what should we say that's going to be? They are made up of opposite rays, okay? And so, and then also the common angle in between. And so adjacent in a linear pair would be angle PQS and SQR angle. Okay, those would be an example of a linear pair made up of angles who are adjacent to each other and not adjacent. Okay. Can you think of two angles that aren't? You're like, they all look like they touch. Well, okay. Take this angle here and then couple that with the one that's furthest from it over here. Do you see how they have a common vertex, but they don't have a common side? So that would be angle PQT and angle SQR. There you go. Do complementary angles have to be adjacent? No. They could be. They just have to equal 90 degrees when you add them up. Okay. And so like if you had 20 degrees and 70 degrees, they might be next to each other, or they might not be. Okay. If this is 20 and this is 70, those will be complementary. They may or may not be even in the same state. Okay. What is the complement of 60? It's a really fun game. What number has to work with 60 to get to be its complement? That's 30 degrees. Their sum is 90 degrees on a complement. To be a supplement, 60 degrees and what have to make a supplement? Well, that would be 120 because a supplement has to equal 180 degrees total. Okay, so those guys are supplements of each other. Okay. Excuse me, that's use some vocab. Okay, for the vocab, if you're talking about angle 1 and 2, what is the best word that we could use to talk about angle 1 and 2? That would be adjacent. We don't know if they're complementary, where they don't look like they can make a straight line, so they're not supplementary. They're not vertical angles. They're not across from each other on an X. Okay, so adjacent would be the best word for us here. Angle 1 which is right here, and XVW. So XVW, XVW, XVW. It's gonna be right here. Okay, what's true about those two angles? Well, they definitely have a common vertex and common side, okay? So they're going to be adjacent, but they're also going to be a linear pair. Notice they have the opposite rays going on, don't they? And this makes 180 degrees. Okay, angle 1 and 3. Okay, so if we look at this, we could say that angle 1 is here and angle 3 is here. Are they adjacent? No, they have a common vertex, but they don't have a common side. So they're not adjacent. It doesn't look like we don't know that they make 90 degrees or 180. So we're just going to say non-adjacent. Okay, next one, angle 1 and 4. Well, the truth is this. Do you notice that these two angles are opposite each other on an X? So they will be called vertical angles. And they're going to be congruent to each other. Okay, and then how about 3 and 4? So here's 3. And here's 4. They're definitely adjacent because they have a common vertex at V. They have a common side, which is this one right here. So I would just say adjacent would be a good choice. We don't know what their sum is. It doesn't look like it's 180. It's not a linear pair. 1 and 5. Okay, here we go for 1. And then 5. Ooh, this is going to be special. Okay, notice that they're adjacent to each other. Common side, common vertex, but also they form a straight line. Okay, you've got opposite angles or opposite rays. And then, so it is going to be a linear pair. Which means that those two angles will be supplementary to each other as well. Okay, great. Okay, now let's do a little bit of math with this. Okay, we've got a couple questions we're going to practice on. We're going to do 3. Lines A and L are perpendicular to each other. So we're going to draw line A and line L. And we know they meet at a right angle. They intersect to form adjacent angles 1 and 2. Okay, so let's call them angles 1 and 2. Okay, measure of angle 1 is 4C plus 22. That's this angle here. And then angle 2 is 3D minus 15. It's a minus sign. Let me erase it and fix it for us. Minus 15. Let's just find the measure of both C, the value of both C and D. Okay, my question is this. They said they're perpendicular. That means this angle is 90 degrees. So the truth is that we know that this couple things, okay? We know that both of these are 90 degrees. We know that this is a linear pair, so that makes 180. But the thing is that if you set 4C plus 22 equals to this right here, they have 2 different letters, so that's not going to help you. But what we do know is that right here, 3D minus 15 actually is a 90-degree angle itself. So that's a really good equation to start with. And so we can add 15 to both sides. We can say 3D is equal to 105, divide by 3, and then D is equal to 35 degrees. Actually, not 35, just 35, okay? It's not an angle. The next thing is, over on this side, we know that if this is 90 degrees, well, then we also know that over here, this angle's 90 degrees as well. So therefore, if we can set this equal to 90 degrees and solve that resulting equation. So like 4c plus 22 equals 90 degrees. Let's solve it. And then c divide by 4, and c is equal to 17. Okay, so sometimes you're going to add them up to equal the whole. Sometimes you're going to say, I know the value of each location. So we're going to write a quick little equation and solve it. You just kind of have to watch and say, what do I know? And then what kind of equation would make sense for me to do? What kind of angles are these right here? Well, I see an X, and they make a V, don't they? If they're opposite each other on an X, and so therefore they are vertical angles, and all vertical angles are congruent. So 2X plus 33 equals 75 degrees. You minus 33 from both sides. You get 2x is equal to 42, x is equal to 21. They want you to actually find the value of each side. Well, we know that 75, and I bet you if we plug in x is 21, you would do 2 times 21, and you add 33, and guess what you're going to get? 75 degrees, okay? 42 plus 33 does indeed equal 75 degrees. So it does check. The other thing is over here, okay? And sometimes you've got to be a little bit creative. I see an X, so there are opposite angles. The problem being that, yes, this is a vertical angle with this right here, but if you just go ahead and set them equal, you'll have both an X and a Y in the equation, which is not ideal. So let's think about what else could be true or is true. Well, this angle here and this angle right here, notice they form a linear pair. So guess what? Those only have x's in them together. So if we want to find their sum, the sum of 9x plus 15 plus 8x plus 12 equals 180 degrees. They're a linear pair. You see that? The opposite angles going on. We've got the angle, the ray that divides them. The sum of those two angles equals 180 degrees. So we've got a couple things that are true, but what helps us is to notice that these are a linear pair. So 17x plus 27 equals 180. You minus 27 from both sides. You're going to get 17x is equal to 153. Divide both sides by 17. You get x equals 9. Now, the truth is, it says find both x and y. So we found x to be 9, okay? And the question is, how can you find y? Well, we can use it to help us find a missing value, okay? If we know that x is 9, well, then we can use that to say, okay, well, then let's find the length of the measure this angle. 9 times 9 plus 15 is going to give us the measure of this angle. And that is going to be 81 plus 15, 91, 96 degrees. So guess what? If this is 96 degrees, what do we know? We know this is 96 degrees as well. And so this is 96 degrees. Okay. All right. So we did a couple steps. All right. Let's practice it up and let's see if we can make some progress. Thank you so much. I hope you guys have a great day.